So as we continue, we're going to look at a slightly different molecule, still one with carbon and hydrogen, but now that also has an oxygen atom in it. Just to show an example where we have multiple elements, more than just two, and that we can still follow this exact same process. So this molecule just happens to be a molecule called methylvinyl ketone, one that I've worked with in my lab, which is why I picked it. Okay, so the first thing we'll need to do this to find what is the percent composition of each element in methylvinyl ketone is that we'll need to know what's the molar mass of the total for methylvinyl ketone. So that'll be 4 times our atomic weight of carbon plus 6 times hydrogen, 1.008 grams per mole. Again, these values are just coming straight from the periodic table. I don't expect you to have them memorized. I've just got these in my head, but you don't need to worry about memorizing these. Use the periodic table to double check your values here. And then oxygen is 16.00 grams per mole. So if we add all those up, we get a molecular mass of 4 times 12.01 plus 6 times 1.008 plus 16 gives us 70.088 grams per mole. All right, so that is the mass of a mole of methylvinyl ketone. So now we can think, well, we have our 4 carbons. What's the mass of a mole of that? We've got 6 hydrogens. What's the mass of a mole of that? And then 1 oxygen. What's the mass of a mole of that? And here, basically, we're just going to use each of the parts that we added together, here, here, and here, to find these different parts. So our 4 carbons is 4 times 12.01 grams per mole. Our 6 hydrogens is the 6 times 1.008 grams per mole. And our 1 oxygen is just, we're already done. It's 16 grams per mole. Okay, and here we're going to get 48.04 in those 4 carbon atoms. Here we'll get 6.048 grams per mole, and we already did oxygen. So now to find the percent of each of these, we now need to take each of these values divided by our total molar mass. So let's just go ahead and do that real quick. So for carbon, our percent composition of carbon is equal to our 48.04 divided by 70.088. I'm just going to leave off the units because they're going to cancel to the same, both grams per mole, just to save me a little bit of writing. I would encourage you to always include the units in your calculations so you don't get mixed up on those. Okay, so 48.04 divided by 70.088 times 100 gives us 68.54%. Our percent of hydrogen is equal to our 6.048 divided by the 70.088 times 100%. And here we need to calculate each of them because we can't just subtract from 100, but it's good to do this anyway to make sure you didn't mess up any of your calculations. So we get a pretty small fraction, only 8.629%. So the carbon and hydrogen just weigh a lot more, or carbon and oxygen just weigh a lot more than hydrogen, so they take up a lot more of the percent of the mass. And then our percentage of oxygen is equal to 16.00 divided by 70.088 times 100%. (16) divided by 70.088 times 100 gives us 22.83. Okay, so there's an example, same process, just now with 3 different atoms, and we could extend this to more complicated molecules, but you get the idea. And remember, these percentages that we're listing, they're all mass percentages, meaning that it's the percent of a mass of this compound that is, the different atoms. So methylvinyl ketone is primarily, the mass is mostly carbon, with a little bit of hydrogen and a significant portion of oxygen that's present as well. Now, the next thing we're going to do is link this idea of percent composition to figure out how can we find, for an unknown compound, maybe we make something in the lab and we want to find out what is the formula for that compound. Well, we can't measure formulas directly unless you have a microscope where you can look at each individual atom. What we can do instead is measure these percent compositions, and in the next video we'll look at taking these percent compositions and going backwards and finding what is the formula for the compound from the percent compositions.